Hi. Make yourself comfortable and enjoy our presentation. Our robot is controlled by our Android application via Bluetooth. The app looks like this, and we use the slider to control the movement of the robot. The Android app issues commands to the robot using 4-byte data packets. To control the robot, there are 4 types of data packets or commands. The firmware of our robot is implemented using 6 tasks. They are in ascending priority. Firstly, our serial task polls the serial input buffer for the 4-byte packets 1 byte at a time. Once it has a packet, it will use it to synchronize the other tasks. Secondly, for the back LED tasks, we synchronize them with the serial task by manually suspending and resuming the respective tasks. We use a local flag in the serial task to track the required blinking state of the black LED. Thirdly, when serial receives movement commands, it sends task notifications to the T-front LED task to light the first LED. Since the movement packets such as forward and backward commands are sent periodically at a rate of 50 milliseconds, we code it such that the lighted LED will cycle through the 8 LEDs continuously as long as the movement packets are still received. It sounds a bit hacky, but it works. Fourthly, when forward or backward button is pressed on the app will constantly send forward-backward movement packets to the robot at a rate of 50 until the stop button is pressed. When the serial task receives these packets, it will send them to the motor message queue asynchronously. The T-motor task will block until it receives these packets and calculate the appropriate PWM values which will be written to the motor drivers. Lastly, the task T-audio song task plays the Baby Shark tune from the start till the end of the challenge run. We synchronize the task by manually suspending and resuming the task from the serial task, and we use the local flag within the serial task to control when the song is played. Here are the 2 difficulties that we had. Firstly, we had problems choosing the appropriate stack size for the tasks. If we didn't allocate a large enough stack size, this would happen. The second difficulty is, the curvature of the turns was not sharp enough when the robot is moving at full speed. You can see it in the video, the turns are much more responsive at low speeds. The problem is that the maker's lap floor is too rough and the momentum of the robot is not allowing the wheels of one side of the robot to stop moving when doing sharp turns. We overcome this by giving some reverse thrust to one side of the wheels so that it will stop moving during sharp turns. Baby Shark, choo 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 choo. Baby Shark, choo 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 choo. Baby Shark.